Tonight we're going to drift through the frozen shells of the outer moons and stand on the edge of hidden abysses. The frost line of our solar system was once viewed as a hard boundary, a cosmic fence where the sun's warmth fails and all water must surrender to a permanent crystalline freeze, expectation, a lifeless wasteland of ice, reality, a paradox where liquid hearts beat in the deepest cold. We are discovering that heat is not always a gift from a star, but a friction born from the violent, invisible grip of gravity. Picture the void beyond Mars, where the light of the sun reaches the outer moons, not as a warming embrace, but as a distant flickering needle in a velvet sky. Here, the temperature drops to a level where the very air would turn to stone. You are floating above a sphere of blinding white, a world of jagged ice and silent craters that seems as dead as the vacuum surrounding it. The silence is absolute, a heavy, oppressive stillness that suggests nothing has moved here for a billion years. But beneath your feet, miles below the scarred crust of frozen nitrogen and water, something is happening. The universe is filing a secret in the depths of these moons. While the surface is a graveyard of absolute zero, the interior is a churning furnace. This is the reversal of everything we believed about the habitable zone. We once thought life required a specific distance from a star to keep water liquid, a golden ring of warmth. But in the outer darkness, the gas giants like Jupiter and Saturn have rewritten the rules. They do not provide light, but they provide a rhythmic, crushing force. As a moon orbits a gas giant, the immense gravity of the planet pulls and stretches the moon's core, kneading the rock like dough. This gravitational friction generates an internal heat that defies the freezing void of space. It is a subterranean fire, an engine of motion that melts the bottom of the ice shell from the inside out. The result is a hidden world, a global ocean trapped in a cage of ice, where the pressure is immense and the darkness is total. These are not the shallow seas of Earth, but abyssal reservoirs that dwarf our own global oceans. They are liquid envelopes, hundreds of kilometers deep, floating between a ceiling of ice and a floor of silicate rock. In this lightless realm, the chemistry of the abyss has run for eons, undisturbed by the chaos of the surface or the radiation of the sun. The water here is not just liquid. It is a solvent, a medium for minerals and salts to migrate from the core into the water, creating a chemical soup that is simmered in the dark for billions of years. The scale of this hidden water is nearly impossible to process. We are talking about volumes of liquid that make the Atlantic and Pacific Oceans seem like small ponds. These moons are not just rocks with a bit of ice. They are water worlds wearing a mask of frost. The ice is a shield, a thick insulating blanket that protects the liquid heart from the vacuum of space, allowing a hidden biology to potentially evolve in a place where the sun is an irrelevant ghost. This internal warmth creates a strange, hypnotic rhythm. The ice crust cracks and heaves, responding to the gravitational tug of the giant planet, creating long, linear fissures that look like tiger stripes across the frozen plains. Through these wounds, the internal ocean sometimes breathes, venting plumes of water vapor and organic molecules into the void, sending a chemical postcard from the deep into the silence of the solar system. We are standing on the edge of a new understanding of the cosmos, where the definition of a sanctuary is no longer a sunny planet, but any place where gravity can generate a spark of warmth. The outer solar system is not a frozen wasteland, but a collection of dark, liquid laboratories. The void is not empty, it is filled with these hidden hearts, beating slowly in the dark, waiting to be understood. But to understand this hidden warmth, we must first look at how we once viewed the edge of the solar system. For decades, the prevailing consensus among the scientific community was that the outer solar system was a vault of silence and stillness. The moons of Jupiter and Saturn were viewed as dormant graveyards, frozen relics of a primordial era where nitrogen and water had locked into a permanent crystalline sleep. There was a quiet certainty that beyond the frost line, the universe had simply run out of energy. The cold was not just a temperature, it was a finality. This belief was anchored in the data gathered during the early 1980s, specifically the flybys of Voyager 1 and Voyager 2. As these probes drifted past the gas giants, they sent back images of surfaces that looked like scarred bone, static, dead ice, cratered by billions of years of impact without a single sign of geological movement. To the observers at NASA and the Jet Propulsion Laboratory during that era, these moons were effectively fossils. They were spheres of rock and ice that had long ago lost their internal heat, leaving them as sterile monuments to the deep freeze of the void. The early NASA assumption was rooted in a terrestrial bias. It was believed that liquid water required a direct, close-range solar orbit. The logic was simple and linear. For water to remain liquid, it needed the warmth of a star. This defined the habitable zone as a narrow golden ring around the sun. If a world drifted too far from the light, the equation ended. The assumption was that without the constant radiation of the sun to provide energy, any water present would inevitably freeze into a solid block of ice, thousands of kilometers thick, forever sealing away any possibility of chemistry or life. In this framework, the outer moons were simply too far. They were ghosts in the dark, existing in a region where the sun is nothing more than a bright, distant needle of light, incapable of warming a single drop of water. The scientific map of the solar system was divided into two distinct realms: the warm, active interior, where the sun dictated the terms of existence, and the cold, dead exterior, where entropy had already won. We looked at the surfaces of Europa and Enceladus and saw only the mask. We saw the white plains and the jagged ridges and assumed the interior mirrored the exterior. We believed that if the surface was frozen, the heart must be frozen as well. It was a comforting simplicity, the idea that life was a rare miracle tied exclusively to the light of a star. This perspective turned the outer solar system into a museum of ice, where the only thing moving was the slow drift of the moons around their massive planetary hosts. The models of the time treated these moons as static bodies. They were viewed as spheres in equilibrium, with the void slowly cooling toward absolute zero. There was no reason to suspect that a world could generate its own warmth from within, especially not on a scale that could melt an entire ocean. The energy requirements were thought to be impossible. To maintain a liquid ocean beneath miles of ice would require a furnace of immense power, and in the silence of the outer system, there were no obvious fires. For years, this was the truth we accepted. We mapped the craters and measured the albedo of the ice, content with the idea that we were looking at dead worlds. We viewed the liquid water of Earth as a cosmic anomaly, a gift of the perfect distance from the sun. The outer moons were the control group in the experiment of life, the places where the absence of warmth proved the necessity of the star. But the universe rarely adheres to the simplicity of our first assumptions. The static images from the Voyager era were not the whole story. They were merely a snapshot of the surface, a veil of frost hiding a deeper, more violent energy. The mistake was in believing that the sun was the only source of heat in the cosmos, we had forgotten that gravity itself is a form of energy, a silent force capable of kneading a world like clay, and yet a new set of measurements began to reveal a rhythmic instability in these moons. The shift in our understanding did not happen with a sudden epiphany, but through the steady, patient accumulation of data from the Cassini-Huygens mission. For years, Enceladus had been nothing more than a small, brilliant white dot in the orbit of Saturn, a moon so reflective that it seemed to be made of pure, pristine snow. It appeared to be the most dormant of worlds, a frozen pearl drifting in the dark. But as Cassini began its close encounters, the images returned something that defied the existing models of planetary science. At the south pole of the moon, the ice was not a solid, unbroken shell. Instead, it was scarred by 4 massive parallel fractures, long gashes in the crust that scientists named the tiger stripes. These fractures were not mere geological cracks. They were wounds. As the spacecraft flew through the southern polar region, the instruments detected something impossible for a world so far from the sun. Massive plumes of water vapor, ice grains, and organic molecules were erupting from the interior, shooting hundreds of kilometers into the vacuum of space. These were not volcanic eruptions of molten rock, but geysers of liquid water, propelled by a pressure that could only come from a vast hidden reservoir. Expectation, a solid sphere of ice. Reality, a world that breathes. The 2017 analysis published in Nature provided the definitive evidence that these plumes were not isolated pockets of slush, but the surface expression of a global subsurface ocean. The data showed that the entire moon was encased in an ice shell, but beneath that shell, a layer of liquid water extended from the crust all the way down to the rocky core. This was not a shallow sea, but a planetary-scale abyss, sealed away from the light of the stars, kept liquid by the relentless gravitational kneading of Saturn. But the presence of water is only the first requirement for life. For biology to emerge, there must be energy and chemistry. In the cold dark of the outer solar system, the surface provides neither. The mystery then shifted from the existence of the ocean to the nature of the floor. If the ocean was simply floating on a layer of ice, it would be a sterile environment, a saltwater tomb with no way to exchange nutrients. The researchers looked deeper, analyzing the chemical composition of the grains captured within the plumes. They found something that changed the conversation entirely: nanometer-sized grains of silica. These tiny particles are the signature of a very specific process. They are created when water, heated to extreme temperatures, reacts with rock. This indicated that the ocean of Enceladus was not just sitting on the surface of the core, but was in direct, violent contact with it. At the very bottom of this midnight ocean, the silicate core is not a dead slab of stone. It is an active furnace. The mission revealed the existence of hydrothermal vents, similar to the black smokers found at the bottom of Earth's own Atlantic and Pacific Oceans. These vents are the places where the moon's internal heat bleeds into the water, creating towering chimneys of minerals and spewing superheated mineral-rich fluids into the abyss. On Earth, these hydrothermal vents are the most concentrated hubs of life in the deep ocean. They are ecosystems that do not rely on the sun. In the crushing pressure of the abyss, bacteria and complex organisms thrive on chemosynthesis, turning the chemical energy of the planet's interior into the building blocks of life. The discovery of these vents on Enceladus meant that the moon possessed the 3 essential ingredients for a biological miracle: liquid water, essential chemical elements, and a permanent source of energy. The abyss of Enceladus is a place of total darkness, yet it is far from silent. The interaction between the rocky core and the ocean creates a chemical gradient, a slow, rhythmic pulse of energy that has likely persisted for billions of years. While the surface of the moon is a wasteland of frozen nitrogen and oxygen, just a few kilometers beneath the ice there is a world of warmth and chemistry. The water there is not stagnant. It is circulating, driven by the heat of the vents, carrying minerals from the core up toward the ice shell, where they are occasionally flung into space for us to find. This realization forced a rewrite of the cosmic map. We had spent decades searching for the habitable zone as a ring around a star, believing that life required the warmth of a sun to survive. But Enceladus proved that the habitable zone can be internal. A world can be located in the deepest freeze of the void and still harbor a warm, churning heart. The energy does not come from above, but from the invisible grip of gravity, pulling and stretching the moon in a celestial tug-of-war that generates heat through friction. This internal furnace transforms the moon from a frozen rock into a biological laboratory. The vents at the core provide a sanctuary, a place where the chemistry of life can run undisturbed by the chaos of the surface or the radiation of space. It is a hidden sanctuary, a pocket of liquid possibility tucked away in the shadows of Saturn. The sheer scale of this environment is what truly challenges our intuition. We are used to thinking of oceans as features of a planet's surface, but here the ocean is the dominant feature of the world's interior. The water of Enceladus is not a lake or a sea in the way we understand them. It is a global shell, a planetary layer of liquid that wraps around the core like a shroud. When we compare the volume of these hidden reservoirs to the oceans of our own world, the numbers begin to shift in a way that is difficult to process. The sheer volume of this hidden water defies our terrestrial understanding of scale. To grasp the true scale of these hidden worlds, we have to step away from the maps of Earth. Our intuition is built on the sight of blue horizons and shallow coastlines, but the outer solar system operates on a geometry of depth that is almost impossible to visualize. If we were to take all the water in Earth's oceans and compress it into a single cup, the hidden depths of Ganymede would be a vast lake filling an entire valley. It is a reversal of everything we understand about the distribution of water in our neighborhood. Ganymede, the largest moon in the solar system, does not just have a sea, it possesses a global shell of liquid water, hundreds of kilometers deep, sandwiched between layers of high-pressure ice, that, according to data processed from the Galileo mission and reinforced by later gravitational measurements from the Juno spacecraft, Ganymede's ocean contains more liquid water than all of Earth's oceans combined. This is not a pocket of moisture or a series of subterranean aquifers. It is a planetary-scale reservoir, a midnight blue abyss that dwarfs our own world's entire hydrosphere. When we look at the surface of Ganymede, we see a scarred landscape of ancient craters and dark, grooved terrain. It looks like a dead piece of shale drifting in the cold, but beneath that crust, the scale is staggering. The ocean there is estimated to be up to 800 kilometers thick. To put that in perspective, the deepest point in Earth's ocean, the Challenger Deep, is only about 11 kilometers. The water on Ganymede is not a thin film. It is a massive, crushing volume of liquid that defines the very structure of the moon. This volume of water is not a fluke of nature, but a consequence of the moon's history and its relationship with Jupiter. The sheer mass of the gas giant creates a gravitational grip that refuses to let the moon settle into a frozen sleep. As Ganymede orbits, the planet's gravity kneads the moon's interior like clay, generating a slow, rhythmic heat that prevents the core from solidifying and keeps the water in a liquid state. It is a process of celestial friction, where the movement of an entire world creates the warmth necessary to sustain a global ocean in the dark. The environment within this abyss is one of absolute stillness and unimaginable pressure. There is no wind, no current driven by weather, and no sunlight to penetrate the miles of ice above. Instead, there is a slow, heavy circulation of minerals and salts, moving in a cycle that spans millions of years. The water is not pure. It is a brine saturated with the chemical signatures of the rocky mantle below. In this environment, the concept of a surface disappears. There is only the ceiling of ice and the floor of the core, with a world of liquid shadow in between. We are used to thinking of water as the surface feature that allows life to flourish, but on Ganymede, the water is the hidden engine. It is the dominant physical characteristic of the world, despite being completely invisible from the outside. This shifts our entire understanding of what a water world looks like. We no longer look for the blue marble, we look for the frozen shell that hides a giant, and as we drift further into these depths, we realize that the water is only the beginning. The real mystery lies in how this water interacts with the core, creating a chemical bridge that could sustain something more than just salt and stone. This abundance of water in the dark suggests a terrifyingly calm possibility for the deep time of the cosmos. For decades, the search for life in the cosmos was governed by a simple geometric rule. We looked for the habitable zone, a narrow golden ring around a star where the temperature was just right for water to remain liquid on a planet's surface. Expectation, a cosmic geography where the sun is the only source of warmth. Reality, a universe where the most viable habitats for life may be locked in the absolute dark, millions of miles away from any meaningful sunlight. This realization fundamentally redefines the map of the solar system. It suggests that the traditional habitable zone is not a fixed circle, but a flexible property of gravity. We are discovering that the energy required to sustain an ocean does not have to come from a distant star, but can be generated from within the very heart of a moon. This is the mechanism of tidal heating, a process where the immense gravity of a gas giant like Jupiter or Saturn acts as a cosmic engine, physically stretching and squeezing the moon in a rhythmic, eternal cycle. To understand the scale of this energy, we must look at the physics of the orbit. As a moon moves through its elliptical path, the gravitational pull of the parent planet varies. When the moon is closer, the gravity pulls harder, elongating the moon's shape. As it drifts further away, the grip relaxes and the moon snaps back. This constant deformation creates internal friction on a planetary scale. It is the same principle as bending a metal paperclip back and forth, until the metal becomes hot to the touch, but applied to an entire world of rock and ice. For the moons of the outer solar system, this tidal heating is not a temporary event, but a permanent state of being. While the surface of Europa or Enceladus remains a frozen wasteland, the interior is kept in a state of perpetual agitation. This energy has persisted for billions of years, providing a stable, non-solar heat source that does not flicker or fade like the light of a dying star. It is a slow, rhythmic kneading of the core, a gravitational pulse that ensures the water never fully solidifies into a tomb of ice. This shift in perspective transforms our understanding of biological possibility. If life is bound only to the light of a sun, the universe is a lonely place, with habitable pockets separated by vast, empty voids. But if life can be powered by the rhythmic friction of gravity, then the galaxy is suddenly crowded with potential. Every gas giant in every star system, from the center of the Milky Way to the furthest edge of the observable universe, likely hosts a family of moons with liquid hearts. The dark oceans of the outer solar system are not anomalies. They are the rule. We are moving away from the era of the solar-centric model and entering the era of the gravitational model. In this new framework, the most precious resource is not sunlight, but orbital resonance. When moons orbit in specific ratios, such as the Laplace resonance between Io, Europa, and Ganymede, they tug on one another, amplifying the tidal forces and pumping more heat into their interiors. This celestial dance creates a sustainable furnace, allowing liquid water to exist in regions of space where the ambient temperature is nearly absolute zero. The implications for deep time are profound. A planet orbiting a star is subject to the star's evolution. As a sun grows hotter and expands, it eventually boils the oceans of its children. But the moon, powered by tidal heating, is decoupled from the death of its star. As long as the gas giant remains and the orbital resonance holds, the interior ocean remains liquid. These hidden abysses could potentially harbor life for far longer than the surfaces of Earth-like planets, creating sanctuaries of stability in an ever-changing cosmos. Here is where you come in. As a witness to this reversal of cosmic logic, we once believed that the frost line, the distance from a star where volatiles freeze, marked the end of the habitable world. We saw the outer solar system as a cemetery of ice, but the data from our probes has shown us that the frost line is merely a curtain. Behind it lies a hidden architecture of heat and water, where the darkness is not a barrier, but a protective shield. These oceans are sealed beneath miles of ice, insulating them from the harsh radiation of space and the volatile fluctuations of the solar wind. Inside, the environment is defined by a steady, predictable warmth. It is a world of thermal equilibrium, where the energy flows from the rocky core upward into the water rather than from the sky downward. This creates a vertical ecosystem of energy, a reversal of the terrestrial experience. On Earth, the energy starts at the surface with photosynthesis. In the hidden oceans of the outer moons, the energy starts at the bottom, in the crushing depths of the silicate mantle. This means that if life exists in these depths, it would have no concept of a day or a night. It would know nothing of seasons or stars or the passage of time marked by the movement of a sun. Its entire existence would be defined by the rhythmic pulse of the planet's gravity, a slow, thrumming heartbeat that vibrates through the water. The very concept of a horizon would be replaced by the ceiling of ice and the floor of the abyss. The scale of this energy source is staggering. While the sun provides the energy for the surface of our world, the gravitational kneading of Jupiter provides enough energy to keep an entire moon liquid, regardless of the freezing void surrounding it. It is proof of the power of mass and motion over light and heat. The outer moons are not dead rocks drifting in the cold. They are living engines, converting the kinetic energy of their orbits into the thermal energy of life. As we contemplate these silent, dark laboratories, we realize that the definition of a habitable world has expanded. We are no longer looking for a twin of Earth, but for any world where gravity can create warmth. The search for life has moved from the telescope peering at distant suns to the gravimeter, measuring the subtle tugs of planetary mass. We are searching for the rhythmic friction that turns a frozen sphere into a liquid sanctuary. This gravitational engine creates a world where the chemistry can evolve in total isolation for eons, undisturbed by the chaos of surface impacts or the stripping of the atmosphere. These oceans become closed systems of extreme stability. The water becomes a solvent for a chemistry we are only beginning to understand, a slow-motion reaction spanning billions of years. But the chemistry within these depths is even more alien than the darkness. The silence of the outer solar system is not empty, but filled with a chemical tension that has been building for billions of years. For a long time, the prevailing thought was that these frozen moons were sterile, their interiors locked in a permanent state of crystalline stasis. But as the measurements emerged from the precursors to the James Webb Space Telescope, a different picture began to form. A 2021 study led by the Jet Propulsion Laboratory showed that the plumes erupting from Europa are not merely sprays of pure water. They are carrying something far more significant. The data revealed the presence of complex organic molecules and salts, transforming our understanding of these moons from simple reservoirs of ice into vast chemical soups capable of sustaining an actual metabolism. This is not the sterile water of a glacier, but a nutrient-rich brine. When we look at the composition of these plumes, we find the fingerprints of a world that is actively breathing. The detection of sodium chloride, common table salt, and various carbonates is the key to this mystery. These are not random occurrences. Their presence indicates a direct, violent, and constant chemical exchange between the liquid ocean and the rocky silicate mantle beneath it. On Earth, this is the same process that happens at the bottom of our own oceans, where the crust meets the magma of the interior. Here, in the freezing dark of Jupiter's orbit, the same dialogue is happening. The water is leaching minerals from the rock, and the rock is fueling the water. This interaction creates a pH balance and a mineral gradient that acts as a battery. In the absence of sunlight, this chemical imbalance becomes the primary source of energy. It is a slow, steady leak of power from the core of the moon into the depths of the abyss. If life exists there, it does not eat light, but eats the very chemistry of the moon's heart. It survives on the friction between stone and water, turning the decay of minerals into the building blocks of biological complexity. The carbonates found in the plumes suggest that the ocean is not just sitting there, but is circulating, pulling nutrients from the deep and pushing them up toward the ice ceiling. To understand the scale of this chemical engine, we have to look at the volume of the exchange. We are talking about an entire global ocean, hundreds of kilometers deep, pressing against a metallic and rocky core. The pressure at the bottom of Europa's ocean is immense, far exceeding the depths of the Mariana Trench. Under this weight, the water becomes a super solvent, dissolving the mantle in a way that creates a rich alkaline environment. This is where the precursors of life, the amino acids and the complex carbon chains, would find a sanctuary. The plumes we see erupting into space are merely the exhaust of a massive subterranean laboratory that has been running in total isolation since the dawn of the solar system. This chemical soup is not a fluke of nature, but a predictable result of the moon's internal structure. The sodium chloride tells us that the water has been in contact with the rocky interior for eons, scrubbing the minerals from the crust and distributing them through the water column. It means the ocean is not a stagnant pond, but a dynamic system. There are currents in that dark water driven by the heat of the core and the pull of Jupiter's gravity, moving organic compounds from the depths to the surface. Every plume that shoots into the vacuum of space is a postcard from a hidden world, carrying a sample of the internal chemistry for us to decode. When we analyze these molecules, we aren't just looking at chemistry, we are looking at the potential for a biological history. The presence of organics means the raw materials are there, the salts mean the environment is conductive and chemically active, the carbonates mean the water is interacting with the rock. All three of these conditions, energy, water, and chemistry, are the holy trinity of habitability. We used to think these were rare ingredients found only on a lucky planet like Earth. Now, the data from the Jet Propulsion Laboratory suggests that these ingredients are standard equipment for any moon caught in the gravitational grip of a gas giant. The abyss is not a void, but a crowded space of molecular interactions. Every cubic centimeter of that hidden ocean is a site of potential reaction. The molecules are dancing in the dark, colliding and bonding, building larger and more complex structures. It is a process of slow accumulation. Over 4 billion years, a simple chemical soup can evolve into something far more sophisticated. The stability of these oceans is their greatest strength. While the surface of Earth has been scorched by gamma-ray bursts and frozen by ice ages, the depths of Europa have remained constant. The temperature has not shifted by more than a few degrees in eons. The chemistry has had the luxury of time, undisturbed by the chaos of the surface. We are seeing a pattern emerge across the outer solar system, from the hydrothermal vents of Enceladus to the salty depths of Europa. The signature is the same. The universe is not making just one habitable world. It is making dozens of them, hiding them inside shells of ice to protect them from the radiation of space. The ice is not a barrier, but a shield. It keeps the internal heat trapped and the external vacuum out, creating a perfect pressurized greenhouse. In this sanctuary, the chemical exchange between the mantle and the ocean can proceed without interruption, carving out a niche where life is not just possible, but perhaps inevitable. The detection of these salts and organics changes the goal of our future missions. We are no longer asking if there is water, but what that water is doing. We are looking for the specific ratios of sodium and carbonate that would indicate an active biological process. We are searching for the waste products of a metabolism that functions in the dark. The plumes are our only window into this world, providing a free sample of the abyss without the need to drill through 20 kilometers of ice. Every grain of salt captured by a probe is a piece of evidence that the outer solar system is far more active than we ever dared to imagine. As we process this data, the scale of the possibility becomes overwhelming. If every large moon in the outer solar system has a similar chemical engine, then the number of potential habitats in our own backyard is astronomical. We are not living on the only oasis in a desert, but in one of many hidden gardens. The dark oceans of the outer moons are not anomalies. They are a fundamental feature of how planetary systems are built. The gravity of a giant planet is a sculptor carving out liquid voids in the hearts of frozen moons and filling them with the chemistry of life. The realization is that the darkness is not a place of death, but a place of preservation. The hidden oceans are the great archives of the solar system, holding on to the original chemistry of the nebula from which we all formed. By studying the salts and the organics of Europa, we are essentially reading the blueprints of our own existence. We are seeing the same reactions, the same mineral exchanges, and the same thermal gradients that likely sparked the first cells in the deep vents of Earth's ancient seas. The outer moons are not just alien worlds, they are mirrors reflecting the same laws of chemistry and physics that created us. And as we drift further into the silence, we realize these moons are mirrors of our own origin. And yet there is a place where the water does not merely exist, but screams. To understand the true scale of these hidden oceans, we must drift further past the rings of Saturn to the moon Titan. For decades, the consensus was that Titan was a world of hydrocarbons, a frozen wasteland of liquid methane and ethane raining from a thick orange haze. Expectation, a sterile chemistry of fuel and gas. Reality, a hidden saltwater abyss that may be the most stable environment for life in the entire solar system. The 2017 analysis of data from the Cassini mission, published in Nature, suggested that Titan hides a global ocean beneath its thick ice shell. But unlike the oceans of Europa or Enceladus, Titan's water is locked far deeper, separated from the surface by a crust of ice that could be 60 miles thick. This creates a profound isolation. The surface is a laboratory of organic chemistry, where complex molecules drift like snow, but the ocean below is a silent, dark reservoir, disconnected from the sunlight and the methane rains above. Imagine the scale of this separation. If the ice crust of Titan were a wall, it would be a mountain range that stretches across the entire world, a barrier so immense that no signal from the surface could ever reach the water. Below this ceiling, the ocean is not just a pool of water, but a chemical soup, potentially enriched by the organic compounds that slowly seep through the ice over millions of years. It is a slow-motion infusion, a cosmic drip where the surface world feeds the deep world one molecule at a time. The gravity of Saturn pulls and pushes on Titan in a rhythmic, invisible tide. This gravitational kneading generates internal heat, preventing the ocean from freezing solid even in the crushing cold of the outer rim. It is a heat that does not come from a sun, but from the very geometry of the solar system. This is the true paradox of the outer moons. The further we move from the warmth of the stars, the more we find the universe creating its own heat in the dark. If we consider the volume, Titan's hidden ocean may hold more water than all of Earth's oceans combined. We are talking about a mass of liquid that dwarfs our own global seas, a continent of water that has remained undisturbed for billions of years. In this abyss, the pressure is so great that the water may take on different phases, forming exotic ices that act as a floor, separating the liquid from the rocky core. Here is where the scale becomes impossible to process. We often think of the habitable zone as a thin ring around a star, a Goldilocks strip where water can be liquid on a planet's surface. But the discovery of Titan's ocean and those of Ganymede and Callisto reveals that the habitable zone is not a ring, but a series of pockets. The universe is not just habitable in the light, it is habitable in the deep. The dark oceans are not exceptions to the rule, they may be the rule. The 2023 studies using the James Webb Space Telescope have begun to map the atmospheric fingerprints of these worlds, looking for the chemical leaks that signal an active interior. We are finding that the outer solar system is not a graveyard of frozen rocks, but a network of hidden hearts, each beating with a different frequency of tidal heat. These are the silent archives of the cosmos, where the ingredients for life have been simmering in the dark, far from the sterilizing radiation of the sun, waiting in a stillness that spans eons. And yet, the mystery deepens when we shift our gaze from the giants of Saturn to the smallest of the active worlds, a moon known as Enceladus. For decades, the academic consensus was that a body so small, only 500 kilometers across, should have lost its internal heat billions of years ago. Expectation, a cold, dead husk of ice. Reality, a world that breathes. The Cassini mission, managed by NASA, provided the first concrete evidence of this anomaly. As the spacecraft flew through the plumes of water vapor erupting from the South Pole, the instruments detected something far more significant than simple water. They found organic molecules and, more crucially, molecular hydrogen. In a 2017 paper published in Nature, researchers concluded that this hydrogen is the result of hydrothermal activity on the ocean floor. Picture the scene at the bottom of that midnight abyss. There is no sunlight, no wind, and no surface. Instead, there are towering vents of silicate rock, glowing with a dim thermal heat, spewing minerals into the freezing water. This is a process called serpentinization, where the interaction between water and rock creates a chemical energy source. On Earth, these same hydrothermal vents in the deep Atlantic and Pacific Oceans are teeming with life, from giant tube worms to blind shrimp, all surviving without a single photon of light from the sun. If we translate this to the scale of Enceladus, we find a hidden laboratory where the energy for life is not harvested from the sky, but mined from the core. The ocean is not just a reservoir, it is a chemical engine. The water is pushed through the rocky interior, absorbing minerals and heat before being forced back up through the ice crust in those violent, ghostly plumes. This reveals a profound shift in our understanding of cosmic biology. We used to believe that life required a star, a source of radiation, to drive photosynthesis. But the data from Enceladus suggests that the universe can sustain life through gravity alone. The rhythmic kneading of Saturn's massive gravity stretches and compresses the moon, generating friction that keeps the water liquid and the vents active. Here is where the implication becomes quiet and vast. If life can emerge in the dark, pressurized depths of a small moon, like Enceladus, then the number of potentially habitable worlds in the galaxy does not just increase, it explodes. We are no longer looking for a few rare planets in a Goldilocks zone. We are looking at a universe where almost every gas giant in every solar system could be hosting a hidden ocean. The void is not empty. The frozen wastes of the outer rim are not deserts, but veils hiding a liquid architecture that may be the most common habitat in the observable universe. We drift now into the final stillness, leaving the chemical plumes and the gravitational tides behind. We have traveled past the frost line, where the warmth of the sun is nothing more than a distant, cold needle of light, and we have seen that the darkness is not an empty void, but a sanctuary. The outer moons have taught us that the requirements for life are far more flexible than our early maps suggested. We once believed that the spark of existence required the direct gaze of a star, a specific distance measured in astronomical units, and a thin atmosphere to shield the surface. Now, we know that the universe preserves its secrets in the deep, beneath shells of ice so thick they would dwarf the highest mountains of Earth. The scale of these hidden worlds remains the most haunting realization of all. We are looking at planetary bodies that carry more water in their dark, pressurized depths than our entire world possesses on its surface. This means that the most common habitat for liquid water in our solar system is not the blue marble we call home, but the silent frozen spheres of the outer rim. We are the anomaly. We are the surface dwellers, the creatures of the light, while the rest of the solar system breathes in the crushing pressure of the abyss. The chemistry we found in the plumes of Enceladus and the salts of Europa suggests that the machinery of life is not a terrestrial fluke, but a cosmic inevitability waiting to be triggered wherever heat meets water and rock. If we could descend through those 20 kilometers of ice, we would find a world that has never known a sunrise, never known a season, and never known the wind. We would find a global ocean that has remained stable for billions of years, undisturbed by the asteroid impacts or the atmospheric collapses that have scarred the surfaces of other worlds. It is a cathedral of silence, a place where time is measured not by the rotation of a planet, but by the slow rhythmic kneading of a gas giant's gravity. In these depths, the only light would be the faint ghostly glow of bioluminescence, or the searing amber radiance of hydrothermal vents. As we prepare to leave these moons, we are left with a final singular image. Picture a single glowing amber core, a silicate heart radiating heat into the midnight blue of a subsurface sea, all held beneath miles of silent white ice. This core is the engine. It is the furnace that defies the vacuum of space. It is the only reason these oceans exist, turning a frozen wasteland into a living laboratory. This small glowing ember is the bridge between the dead cold of the void and the warmth of biological possibility. It is the same kind of energy that likely fueled the first microbes in the deep vents of Earth's ancient oceans billions of years ago. We find ourselves wondering if these amber cores are lighting the way for something else. If there are eyes in those depths, they have never seen a star. They have never seen a moon or a planet. Their entire universe is a ceiling of ice and a floor of fire. For them, the surface of their world is not a place of hope or a gateway to the stars, but a frozen, impenetrable barrier, a ceiling that separates them from a vacuum they cannot even conceive. They would perceive the universe not through light and distance, but through pressure, vibration, and the chemical whispers of the water. If these hidden oceans harbor life, do you think they would evolve to perceive the universe differently than we do? Would they even understand the concept of a star, or would they believe that the only truth in existence is the warmth of the core and the weight of the water above them? We are only beginning to understand the true scale of these hidden gardens. Each probe we send, each grain of salt we capture, and each measurement of gravity we record is a page turned in a book that has been written over 4 billion years. We are no longer searching for a second Earth. We are searching for the original blueprint of life. A blueprint that may be more common in the dark than it ever was in the light. The outer moons are not just satellites of gas giants. They are the great archives of the solar system, holding the memories of the nebula from which we were all born. The journey through the ice concludes here, but the mystery only deepens. We leave these worlds to their eternal rhythmic dance, floating in the indigo void, keeping their secrets sealed beneath the frost. We return now to the comfort of the stillness, carrying the knowledge that we are not alone in our need for warmth, and that the cosmos is far more crowded with potential than we ever dared to dream. Sleep well tonight, and tomorrow we will continue to explore the deepest mysteries of the cosmic void. Subscribe to. Join us on our next journey through the stars.